Hello everyone. Thank you so much for joining us today. My name is Salma Avdic, and on behalf of the American Marketing Association, I'd like to welcome you to our webcast for today. This is sponsored by Cardinal Path, entitled Applying Data Science Methods for Marketing Lift. So before we get started, I just quickly wanted to cover a few housekeeping items. This session is being recorded, and recording will be made available to you soon. We also encourage everyone to continue the conversation on Twitter, and you can do so by referencing #DataScience. And if you have any technical or content-related questions, please feel free to type them in the chat area that's located on the left-hand side of your screen, and we will address those at the end of the presentation. So with that, I'm very happy to turn things over to Charlotte to get us started.
Good morning, everyone. Thank you so much for joining today's webinar on data science methods for digital marketing optimization. My name, as Selma said, is Charlotte Bourne. I'm the manager here at Cardinal Path in the data science department, and I have quite a bit of experience over in the field of web analytics. I'm going to be talking today about some of the range of applications that are available for digital marketers in the realm of predictive analytics. And also on the call with me today is Danika Law. Danika is a consultant in our digital intelligence practice on the data science side. She has a wealth of experience in statistical and machine learning models. Danika's experience includes working for Statistics Canada, which is the Canadian government's national statistical agency. So when you registered for the webinar, we asked you what it was that you wanted to know about this topic area. And the responses we got were incredibly broad, as you can see just by this word cloud that you're looking at. Some people were looking for general information. Other people were looking for some very, very specific data science questions to be answered. And some people were just looking for new ideas about what data science methods could be used. So in this webinar, what we're going to do is give you a small sample of what are pretty fundamentally very different data science approaches. What we're trying to show you is just the breadth of options that are available out there. And what we want you to take away is that data science just has a huge range of applications. So hopefully you're going to get some new ideas for your own organization just based on what you're going to see here today. So the topics we're going to touch on are forecasting, customer lifetime value, and text analytics. We also took a look at some of the questions that came through the registration form, and we're going to touch on some of those at the end of the webinar. This webinar is also being recorded, and everyone who registered will get an email with the link to the on-demand version, along with a bunch of different assets, including our data science playbook, which summarizes 16 different data science methods that you could potentially use in your own organization. One of the reasons why we picked this as a topic is just out of the sheer potential opportunity. The online space is great for a lot of different things, but one of them is just generating volumes of data, and digital marketing is no exception. Because there is so much data being generated, this lends really, really well to data science techniques, which can be trained on and can execute on that same data. Some organizations consider and build data science programs as a continuation of their business intelligence departments. But one of the main differences is that while business intelligence is a little bit more backwards looking and maybe more of a reporting based view, data science changes that to a more forward looking predictive view. One of the first things you're going to need to think about as you bring data science into your organization is staffing. And one of the big challenges with this field is just the large number of skill sets that's required to successfully execute a data science project. We've created our own data science Venn diagram. This works particularly well for our own organization here at Cardinal Path. If you Google data science Venn diagram, you're going to see a lot of different variants out there, some which may fit for your own organizations a little bit better. But what you're generally going to see is these 4 skill sets need to be represented. The first is the area of math and statistics. Second is the area of visualization and communication. Third, particularly if you're dealing with large data sets, we start thinking about databases and computer programming. And then you also need, ideally, domain expertise to understand what the results mean so that they're actually more applicable. So to try and find someone with all 4 of these skills is really difficult, and it's sometimes referred to as the data science unicorn, which is of course a rare and mythical and perhaps not even a real type of animal. So one thing we do to get around this problem of trying to find someone with just an incredibly broad skill set range is we hire for single areas of data science expertise and then make sure that all the different core skills are covered within our data science department. So everyone on our data science team can actually play in more than one of these different data science areas, but we always have a really, really strong go-to resource for each key area. And our philosophy is that data science is a team sport, and that the team together can provide stronger support to a project than any one person alone can. When you first get started with data science, it helps to understand the overall workflow of a project. And one of the models we like to use is known as CRISP-DM, which stands for the Cross-Industry Standard Process for Data Mining. This works really well as a way of understanding how a data science project typically executes. And the idea here is that each stage is potentially iterative. You can proceed along the path of delivering a data science project, but depending on what you find in the data or depending on what you find in your models, you may need to loop back to earlier steps just to better refine your project. But the key point and the main point of reference for any data science project, it always needs to be the very first step here, and that is business requirements. If you execute a data science project without having the goals of the business in mind, you can sometimes develop really complex pieces of work that end up driving no value for your organization. So that's, you should expect that when data science projects, they're going to change as they execute. Just always keep in mind what those final business requirements are.
Hey Charlotte, on the slide, can you maybe give an example of when you would go back in the data science project? I mean, that might be a little counterintuitive going backwards in the process.
Yeah, that's a really good point. One project we worked on a little bit earlier this year was for it's a Fortune 500 company, and they had launched, it was a really big consumer-based campaign, and it was targeting a large number of people. And what they were trying to figure out was who was their audience and who was really responding really well to this campaign. So we said, well, we can model this out. We can make a response model. And in more technical data science terms, that's called logistic regression, which was the method we were using. So we knew the business requirements, understanding the audience, and we also had the data set available. But before we went down the path of modeling, we took a deep dive into the data set. And that's when we found that we weren't actually seeing a whole lot of differences between some of the different demographic variables, which means that demographic variables, at least for this client, were not predictive. So if we hadn't done that initial data exploration step, we could have proceeded all the way to modeling and then produced a model that provided no value to the client. So instead, we went business requirements, we went data evaluation and data exploration, and then we had to boot back to the business requirements and say, okay, either the requirements need to be slightly changed or we need to come up with a different approach that meets the requirements that we know. And we have a poll up right now. The idea here is to find out a little bit more about what data science topics you're interested in getting insights on. And we've got 4 potential areas here, very broad topics. The ideas are customers, marketing channels, products, or price. And I see the responses are flowing in really quickly here. In our own customer base, we tend to see the clients that we're working with tend to veer a little bit more for the first 2, for customers and marketing channels. And let's close the poll to find out the audience results. Yeah, exact same thing. And it makes a lot of sense to me that we're seeing customers and channels as being key points of interest, just because they usually are areas where you can really move the needle. So with that general introduction about data science and staffing and the execution process, I'm going to hand it over to Danika, and she's going to go into a little bit more detail about some of the specific topics we have here, the first step being forecasting.
Thanks, Charlotte. So what can we forecast? Well, really you can forecast just about anything, any online or offline actions, like your online sales, your display web downloads, just about anything that your website or your offline measurements are measuring. So the sky's the limit with what you can predict here. Of course, you're going to need some data to make those predictions. So you can predict your data based on user attributes, previous time periods, and more. If the data is available, We can assess whether including in the model is going to lead to more or less accurate and useful predictions. But I want to start this off by asking, why do you want to forecast? What is the impact going to be? Are you going to be able to optimize anything as a result of this? So for example, there's a couple of uses you could use your forecast for. You could look at how decreases in revenue occur because of scaling back your advertising budget. Or you can start using it to reduce uncertainty. That way you maybe know what to expect in your business over the next several weeks. Another use case would be using it to clearly and accurately communicate expected goals for your business. So as I said, what you need is something for the algorithm to learn on. The model must be trained. This is why we need to collect lots of rich data before we begin our forecast. And when doing this, it's a good idea to think about what influences a purchase, particularly if you're forecasting sales. So someone might first interact with a business via word of mouth when one of their friends maybe tells them about an interaction with a business. Maybe they see some promotional materials or online advertisement like paid media. Maybe they see some TV ads. And then there are all of those offline and things like TV ads. We also have more vague things like seasonality and how the economy is coming into play. These are all things you should start considering when thinking about creating your forecast.
So Danika, these are all pretty, I think, straightforward and logical things that I would expect to see in a predictive model for forecasting. Are there any variables that you can think of that maybe are a little bit more counterintuitive that maybe people on the call haven't considered?
Yeah, sure. This is maybe a unique case I was dealing with. So on a particular client, they were going to be introducing a new website iteration, and so we expected a lot of the metrics to change drastically at that time as measurement changed and the whole flow of the website changed. So what we did was consider introducing a variable that was sort of an on-off. The first part of it indicated this is a time period when we were on the old website, and then it would switch to this is the time period indicating the new website. And that way we can have two different baselines. So what the measurement is during the pre-period of the new website and the post. And that was a cool way of sort of differentiating between those different measurement times. So after we've considered these different influencers to put into our model, we have to start thinking about evaluating the best approach. And there are two main approaches we might consider here, the statistical and the machine learning approach. And they have different areas where they lend to different and better solutions to different problems. For example, machine learning tends to lead to more accurate but less interpretable models. What this means is it's going to get our predictions almost spot on, as close as possible. However, we're not going to be able to necessarily know how much of a change is due to what. And that's where statistics is better. It's usually better for more interpretable models where we can see how much of a change is due to what. However, we may lose some accuracy in using that approach. There are other things on the slide that talk about how long the model takes to run, which has the lowest error rate, are they difficult to configure, and these are all sort of areas where we need to start considering when we're choosing between the statistical and the machine learning approach. And here at Cardinal Path, we consider these each time. In a Fortune 500 example, we found a methodology that met specific business needs. We chose a machine learning forecast so that we could have increased accuracy, a highly accurate forecast that would let them know what to expect in their business KPIs. And what was important here is we weren't bound by one approach. We were able to adapt our approach to meet their goals, to increase the accuracy. And at Cardinal Path, we take this approach where we evaluate multiple models on all clients. Rather than working with a single methodology, we find a methodology that works best for your specific business needs. We can quickly iterate through a range of models as seen on the right here and find the one that's the winning model, the one that is the best for your approach, be it more accurate or more interpretable. And then we also do an iterative approach here. So what this means is as we get new data, we can update our model. So more old data, historic data, or more recent data. We can also add new variables. So if maybe a new channel is introduced to the mix, we can introduce that data set to increase the accuracy of our model. In the Fortune 500 example, we did just that. We had been originally forecasting using only paid search spend, but then eventually we were able to collect all of the different spend, so display spend, TV spend, email spend, and by using all of these in the model, we were able to iterate and increase the accuracy. So now I'm going to dive a little deeper into that example I've already started talking about. This client spent millions of dollars each month on paid search advertising. So really knowing what to expect in that marketing channel would be a huge asset. Here they wanted to know how many calls, appointments, and quotes to expect based on how much they were going to spend on all channels. By knowing if paid search spend would help them meet their calls targets or not, they could change their budget and respond to what the forecast was telling them they could expect. However, their forecasting attempts in the past weren't getting the accuracy that they needed. Also, they weren't getting the level of detail they needed. They were just forecasting all calls as a huge bucket. There wasn't any breakdown to differentiate between paid search calls, display calls, or any other type of call sources. So with this in mind, we had two goals: improve the accuracy and break down the metrics by marketing channel. So previously, we had known the organization had taken a statistical time series approach. Since, as discussed earlier, we know that machine learning can lead to more accurate models, we moved to this approach. We created many forecasts using many different algorithms and chose the one that led to the best performance. We also broke down each metric into the marketing channels. And in doing this, we were both able to break down and provide a more granular view, but also increase the accuracy by 30% compared to the traditional statistics model. What we do now is we update the forecast once a month, where we bring in more recent data to keep the model fresh and current. Also, we go back and assess whether different models lead to more accurate approaches. So if we go back and test a different approach than the one we chose here and find it's more accurate now, we can change it on the fly. We deliver the forecast as an output of values, expected values, so that they can gauge how much of each website action to expect through the year. And here is just a visualization of what we were looking at during the forecasting process. So the red line is the fitted line, what I predicted. And then the blue line is the actual line. And you can see some deviation there. No forecast is going to be perfect, but we're really narrowing down on what the actual trend is as compared to what the statistical time series approach was previously.
I really like this example. Can you go back a slide? Yeah, I really like this because this is an example from the auto industry, and it's for somebody looking for quote completes for the paid search marketing program. And like every single client I work with has active paid search marketing programs, so it's applicable to everyone. And I thought a kind of interesting counterpoint example to this one would be also from the auto sector. It was a client we worked with earlier this year, and we were giving them a couple different proposals for different forecasting techniques we could do. And they were really interested in auto sales. And we said, sure, we can do auto sales, but it's something a little bit more novel. Auto sales has leading indicators. So we said, what if instead of predicting auto sales, we predict the leading indicator of auto sales? So what we were effectively proposing is to do a forecast of a forecast.
Yeah, that's a really interesting example there, almost a forecast of a forecast. And so here we're going to now talk a little bit about ongoing delivery, how we deliver the output of a forecast. So outputs can be delivered in multiple formats where we manually update them, or we automatically schedule them, or more interestingly, we can deliver them as part of a dashboarding project, in particular through a Tableau R integration. So when delivered as part of a dashboard, we can more easily scale predictive models across sites, brands, and audiences. Dashboards are a great way to see the data and the forecasts all in one place. You can see how the forecast is expected to change based on your advertising budget and more quickly respond to what the forecast is showing you. So for example, if the forecast says sales are going to decrease in November, and the dashboard visualization will allow you to see this more quickly. You'll see that drop in the plot, and maybe you'll be able to respond to that through increasing advertising in particular channels as a responsive measure. So with a Tableau R integration, we can quickly find a high quality forecast using an almost endless range of models. R has tons of different modeling options, R being a statistical software, and it just has a lot of different options that aren't necessarily available in the built-in Tableau forecast. So we can really increase the accuracy here. Then by having it connected to Tableau through a custom integration, all the visualizations and all the predictions are going to live in one spot. This is going to allow for easier updates. And this saves time, which can instead be used to gather insights from the forecast. So how are we going to get started here? First, you should take stock of what data inputs are currently available. Do you have data for previous time periods, so historical data? Do you have any user level data? And think not only about what variables are available, but what about the variables that are going to have an impact on the metric that you're forecasting? So like in the Fortune 500 example we discussed, we knew that all spend, not just paid search spend, is likely to impact their metrics. And so we sought out to get all spend incorporated into the forecast. All spend being display, paid search, paid social, and not just the paid search spend. So adding more data. So it's a good idea to include all these possible data inputs, even if you think they may not be the most relevant, because during the model building process, we can include and exclude that data that leads to the most accurate predictions. So I can test different models and figure out which one works best for the data. This is why including as much data as possible will help us lead to better forecasts. Determine what you want to predict that's going to have the highest impact for your business. Sales can be a good starting point here, but this can be anything. For example, store locator clicks, if that's something that your website is trying to optimize towards. And this goes back to checking what aligns with your business requirements. Think about the why. That's what we sort of obsessively think about here. Why are we doing this project? So it's very important that the business requirements solidly define what we're going to forecast, because these are the things that we're measuring, our key KPIs. Otherwise, you may end up forecasting a metric that has little use in impacting the decisions of your business. So here at Cardinal Path, we frequently do stakeholder interviews to help define those business requirements for you. Getting set off on the right path for these measurements is not only going to equip you for the best forecast possible, but it's going to give all your data projects, forecasting and otherwise, meaning. And that's going to take us into our next topic, but before that, we have a poll question. And this poll asks, what is your biggest challenge when tackling data science? Staff, knowledge, technology, and data volume or quality. So if you're already tackling data science projects, you're probably already encountering some of these challenges. Whereas if you're new to it, these are going to be challenges you'll encounter all along the way. So I'm curious which ones are the biggest ones that people are seeing. So let's give a few moments to get a few more poll answers in. And I think we can stop the poll now and see what the results are. Interesting. So the main challenges here is knowledge and then the data volume and quality. So yeah, I encounter data volume and quality issues quite frequently where we don't have enough data, or going back and checking the quality of the data leads to challenges where we have to maybe collect more data. So really interesting. Thanks there. So what is customer lifetime value? It's important to note that customer lifetime value isn't just what a customer has spent with you so far. That would just be a simple sum of the total revenue by customer. Instead, it's a predictive measure of how much is a customer going to spend with you in the future. Then we can slice in by demographic, behavioral information, and more to identify key patterns. By looking at predicted lifetime value, rather than the amount each customer has spent so far, we can get a sense of how valuable certain customers will be, rather than just how valuable they are now. This is a really important distinction, because if we just look at how much someone has spent with us so far, that means that we are going to undervalue new customers. They haven't had time to build up the revenue history that long-term customers have. So if we could predict how much value a customer is going to have with just recent purchase information, we could use this information much earlier and take action accordingly. So why would you want to use customer lifetime value? So we may have heard about the 80-20 rule. This is saying that 80% of your sales come from 20% of your customers. But this leads to a really important question. Who are those 20% of customers? Can you bring in more of them to drive high amounts of revenue like this? By predicting a customer's lifetime value, we can discover who these 20% of customers are that are driving the bulk of our sales. Then we can look at their behavioral and demographic traits and then use this to find more of them through targeted advertising. Or we can use the information to personalize the experiences of our existing customers. We can also use lifetime value to help determine optimal customer acquisition costs. Often, channel acquisition costs are determined by how much revenue a channel is bringing in But what if we looked at the customer level? That is the channel bringing in high lifetime value customers or low lifetime value customers? Then we could use this as part of determining optimal customer acquisition costs. For example, look at the customer paths on the right. If we only look at the first purchase a channel brings in, paid search is heavily undervalued compared to display. Display is bringing in $100, but paid search is only bringing in $25. But it turns out paid search brought in a higher value customer when we look at the full customer lifetime value. Display is bringing in one-time purchasers, but paid search is bringing in frequent purchasers who will buy with a company over and over again.
Yeah, I really like this example because it reminds me of a client we worked with a couple years ago now, but from the education space. And what they were trying to do is optimize their customer acquisition costs. And they thought that by targeting affiliate and display, they had a very low cost per customer acquisition. But when we ended up looking at the lifetime value, what we found is that while display and affiliate definitely brought people in, and it was students who were enrolling, they didn't tend to last all the way through the educational program, like a 4-year bachelor's degree. So display and affiliate brought in, yeah, low initial customer acquisition costs, but also low customer lifetime value. So when you considered that full view, it actually turned out that the more expensive channels, or at least that appeared to be more expensive if you were just looking at that first customer acquisition cost, they actually ended up bringing in the better lifetime value. So in the end, we were able to make a couple different recommendations to this client. The one was, it looks cheap on paper, but when you consider the bigger picture, you need to change your marketing outreach strategy to find new students and new customers. And then the other one we were able to recommend is when we sliced into the lifetime value at a demographic level, and we were slicing down into zip code, we actually found that certain zip codes tended to produce higher lifetime value students. So we were able to give a couple of different strategic recommendations there that the client was able to incorporate to improve their big customer acquisition costs and lifetime value.
Yeah, and I really like that example too, since it's going through some really surprising findings that help change what the business is doing to help actually drive more revenue and inform their marketing strategy. So thanks. So who would be a good candidate for using lifetime value? By knowing how valuable customers are and how they behave, we can start using this for targeted advertising. For example, say the results of our models say that females aged 18 to 24 living in suburban areas are driving more value for our business than other segments. We can set up display advertising targeting to search for new customers like this. By taking into account a customer's full purchase potential rather than their first purchase, we can begin optimizing our advertising budget, like in the previous slides examples. And finally, we can start setting up some personalization on our website to serve different experiences to different customers based on their lifetime value segments. So maybe you could set it so that low lifetime value customers are served differently priced products, or try some upselling, all in an effort to try to increase their customer lifetime value. So by knowing who has low lifetime value, you know where to spend time trying to increase the purchase value of these customers. I'm going to walk through a couple of customer lifetime value examples, some more concrete models, but first we're going to talk about evaluating data. Data evaluation is one of the first steps in a project, after defining business requirements, of course. So data evaluation is when we explore the data to make sure we have all the data needed for the project and that it meets the modeling needs. The main takeaway that I want to give here is the richer the data, the richer the insights and the impact. At a minimum, we can just use a transaction history. But this isn't going to lead to super rich insights. When we add in information like marketing channel info, or demographic info, or behavioral info, that's when we really start to get this model shining. Because what this does is it layers in information about our clients, not just how frequently they purchase or when they purchase, but more information on where they came from, like in the example where we talked about paid search versus display, or demographic info where we talk about different zip codes, or behavioral info. Maybe on your website there are different cues that happen. For example, people who purchase at certain times of day or who purchase certain product mixes. And maybe these are all different indicators for lifetime value. So looking at them in combination together is going to lead to a really rich insight. Another thing that is important here is that we have good data integration. Data needs to be linked at the customer level. What this means is at a user ID. Without this, the data is going to be disconnected. We won't know how the behavioral information ties to the demographic information or the revenue, and we won't be able to make predictions. So now I'm going to walk through 3 examples of customer lifetime value models, starting with some that require less data than the last one we're going to go through. So first off is a recency, frequency, monetary model. This requires very basic data, just the transaction history. And from this, we're going to derive recency, frequency, and monetary values. What this means is, for recency, is how recently did a customer purchase ago, a short time or a long time ago. The frequency is how often they're purchasing. And the monetary is just how much they're purchasing in sheer revenue. Since we're not putting demographic or behavioral data into this model, we don't get insights for demographics or behaviors. Instead, we're just going to get insights based on how often purchases happen. This can be used to classify existing customers and any future ones, so we know exactly where they are grouped in terms of customer lifetime value.
There's one interesting point on this slide that maybe the participants would have a question about. And on the right, the title of the chart says, "The probability that a customer is alive." I'm sure that most people on the call probably think of all of their customers as being alive. So maybe you can explain that one a little bit more.
Yeah, that's a really good point. So yeah, we probably think of all of our customers as being alive. What this is doing is it's borrowing terminology from an area of statistics called survival analysis, and it's basically just looking at customers who are still a customer of your business are alive, and once they leave your business, once they've churned, they're dead, which is maybe a little morbid way of putting it, but it's just borrowing from the terminology of this area of statistics that the models come from. So it is a funny way of structuring our graphs for sure. The next model also requires just the basic transaction history, but we're going to layer in another dimension here, and that is time. This is a transition probability model. And what we're going to do here is look at how customers change in their demographics, in their groupings, their customer lifetime value groupings over time. So for example, what percent of inactive customers are going to become active sometime, or what percent of active low-value customers are later going to become high value. This again doesn't bring in as much information as the model I'm going to go through next, but we can begin to optimize based on this alone. Finally, we're getting to the type of models where I actually get really excited with. We're working with much richer data, and that means we're actually going to be able to take extreme action on the outputs of it. So this model means we're taking into account not just the transaction history, but at least one of, and hopefully all of, demographic, behavioral, and marketing information. Rather than knowing who has the highest predicted lifetime value based on the recency of purchase, frequency of purchase, and revenue values, we also dive into demographic segments like gender, age, education. We dive into behavioral traits, like as those who visit websites often, infrequently. And then we can look at these in combination with their marketing history. And we seek patterns in this information through clustering and segmenting. We can identify unknown groups of high lifetime values and use this to drive our optimizations. By using exploratory data analysis techniques, we uncover segments and combinations of behaviors and demographics that were previously unknown in driving high value for the business. And this ends up giving us a more encompassing view of who our customers are and which ones are high or low value. Then we can use this information and target advertising, change personalization efforts, and more. How can you get started in doing a customer lifetime value analysis? First, collect the data that will be used to predict lifetime value. Again, this can be user actions, user attributes, and more. The more data you have to put in the model, the richer the actionable insights will be later. The output of the model is the expected customer lifetime value. Depending on the input data source, your customer lifetime value can represent individual customers or particular segments such as gender and age breakdowns. Finally, and most importantly, you're going to want to use the results. Use the results to lower new customer acquisition costs through optimizing your advertising budget. Spend more to acquire customers with high lifetime value and less for those with indicators for low lifetime value. This can significantly improve your marketing return on investment. When you know your high value traits, you can set up flags in the data and identify when a customer moves from low to high value. And then you can personalize the website experience and advertising based on these flags. And more. The more information you put in, the more you're going to get out of this customer lifetime value model. At Cardinal Task, we want to make sure you not only get a high quality model, but that you use the results of the model. We help clients figure out how to act upon the model findings all the time. So in sum, customer lifetime value is a great way to learn more about your high value customers and start using this information.
Great, thank you, Danika. For this final section, we thought we'd shift gears just a little bit. We've been talking about different ways that you can use numbers in data science. And in this section, we're going to give you a few ways where you can use text in data science. But first, we have another polling question. So for those of you who do have active data science programs, we're interested in knowing where you are spending most of your time. So the options here are you spending a lot of time just collecting your data? Is it in cleaning the data? Is it in data evaluation? Are you doing a lot on the refinement of your algorithms and your models? Or is it actually on the understanding of the outputs of your models? And I have a small bet with Danika because I'm pretty sure I know which one's going to come in first, just based on what we see here within our organization, but we'll see if I win that bet. So it looks like the responses have slowed. If we can close the poll. Okay, yeah, so I have barely won my bet. Yeah, it's cleaning data. If you are an active data science practitioner, you know just how much time you can spend on this, getting it to the right format, removing junky data, just merging data together. Just so much time can go into this particular step. Thank you for your responses. So text analytics. Text analytics is exactly what you think it is. It is using analytic techniques and sometimes the realm of natural language processing to understand your text-based data. And it really doesn't matter where your data is coming from. All we're looking for it to be is in text-based form. So a few examples that you might have access to within your own organizations would be emails from customers, web surveys. It could be online comments, it could be web forms, text-based reviews. Social media is a huge source of potential material here. But the ways that you can dig deeper into this different type of data would be through the methods we're going to discuss here. We have topic modeling, and then we have sentiment analysis to discuss. So topic modeling is about understanding really large volumes of text to understand what the major concepts are that are going on within the text-based corpus. So here's an example. If you were trying to review all of the different tweets that happened during the US presidential debate, let's say the first one, and you tried to figure out what the major topics on Twitter were, that would be very overwhelming just because there's so much content available to you. But what topic modeling does is it provides a way of summarizing what the major topics were. And it's much more sophisticated than a word cloud. So that was something you saw in one of our earlier slides. A word cloud is only going to tell you about frequency. But in topic modeling, the algorithm actually understands what words are related together. So for example, a really good topic model should be able to understand that Obamacare and the US health system are conceptually related and actually sit under a single common topic, which would be the US healthcare industry. And then the question is why? Why would you do topic modeling? So really what it's meant to deal with is when you have large volumes of text and just can't sort through it on your own to make understanding of what's going on. So this is an example from a textbook by Audnart. And what you see is underneath art, you've got a bunch of different words. So you see new, film, show, music, etc. So I think anyone on the call would automatically associate words like film and show and music with the topic of arts. But the one that's interesting here is the first one, new. Why did the topic model say new is associated with arts and none of these other subjects? And the reason why is the topic model looked at the documents and it found that new is very frequently in close proximity to these other words that it associates with arts. And this is an example of a pretty good topic modeling because it does that classification quite well. Topic modeling and sentiment analysis go really well hand in hand and working together. The topic models are going to tell you what people are discussing, and then the sentiment analysis is going to tell you if people are viewing different subjects in a positive or a negative light. So here's an example of a topic model that we did internally at Cardinal, and we were analyzing web forum posts. And this is where it gets super interesting. The ways that you can apply topic modeling, particularly on the visualization side, are just fascinating. So what we did, if you think of topic modeling is about understanding how closely related different words are. It's a measure of distance. And a great way of measuring distance between different items is a network graph, which is why you're seeing this cool spider graph on the right-hand side. And so what we can do is, if we were to hover over these different nodes or get more information about the different blue and red elements, we'd understand what other content topics are closely related to the one that we're having interest in. So if you think of the applications, you've got a really interesting way to understand related content for a user who would be interested in a specific area. And then if you think about other ways that you can analyze topic modeling results, you can think about ongoing reporting for how topics are changing over time. Or one thing that we really like to do is analyze how topics are changing in different geographic regions, particularly for international type brands. And this is an example of sentiment analysis. Sentiment analysis in general, I think it's really intuitive to most people. You're just understanding, are people saying positive things or people saying negative things? And in this example, we're looking at individual tweets. And so for this particular sample of tweets that we took, you can see it's skewing a little bit to the right. And that's on the right, we have the more positive view. So in this particular sample, people are saying generally positive things. And again, where this gets interesting is not in the sum of everything that's going on, it's when you start slicing into it in different dimensions. The dimensions that you choose are always just going to be the ones that are most interest to your business, but really good ones could be, again, geographic segmentation is a good one, segmentation by brand, segmentation by topic.
Yeah, and another example, do you want to go back to that slide, Charlotte? Thanks. So another example of sentiment analysis I've seen is one of Yelp restaurant reviews. So what you can do there is look into Yelp restaurant reviews and sense whether there's positive or negative feelings about specific restaurants. And so obviously words like awesome, delicious indicate positive sentiment, but there's some surprising things that can be found in analyzing restaurant reviews, like people and try end up being positive, possibly because the restaurant's trying to meet all of your needs, or negative things like minutes. Maybe you waited 30 minutes for your food. And by analyzing how people are feeling about a restaurant over time, maybe you can go back to the specific restaurants and use this to have a feedback for the staff and change how you're running your day-to-day business.
Excellent. So there's a lot of different ways that you can execute on topic modeling and sentiment analysis. You could, if you are an avid R or Python user, there are already packages available for those tools that you can access to get up and running with these different models. There are also a large number of vendors available in this space. So I have an example here of something that was posted by Yuri Katin, where he did an analysis of different natural language processing eyes and how they work in terms of entity extraction. And so this is really important if you are working in a domain-specific space, because these type of models, you really want to make sure they work for your particular domain. Sometimes the underlying models will need to be trained to work a little bit better for your industry. So when you are considering your vendors, here are the different things to keep in mind. Very first one, number of languages supported, making sure that all the languages that you have access to are represented in the API that you, or the vendor that you're trying to use. The second is that area of domain expertise. So if a sentiment analysis model has been trained on computer software content, it's going to do well for other computer software vendors in the space. But if it's a model that's never seen that topic before, it may have trouble figuring out what's going on. The number three is what type of features are extracted, and this is starting to get into a little bit about the additional services that could be available. Most vendors that are out there, they don't just do one thing. They actually have a bunch of different services and can give you a bunch of different information. So take a look to see what is offered and what meets the needs of your business the best. And one thing I noticed with a lot of the natural language processing vendors is some of them are providing the ability to integrate with other platforms. I see Twitter integration on a lot of them. So if there are specific integrations with either analytics or social media platforms that you need, definitely take a look to make sure you find a vendor who can provide you with that. And then the final one here is quite obviously cost. These all come at very, very different cost points. So what do you need to get started in text analytics? It's literally just text. That's all you need. The output can be incredibly varied. So we had one example where we were showing you a visualization of how topics were related. Another area would be just a deeper understanding of what topics are being discussed by your customers and how those topics may be changing over time. And then the final one is if you're thinking more about sentiment analysis, the output here is about understanding the sentiment of your customers over time. So the way to use this, because social media is so text-based, this can do a great job at informing your social media campaigns. You can track the sentiment of your customers over time, see if it's improving or if there's some problems. And then one of the just core uses is if you got large volumes of text-based data, this is a great way to dive into it a little bit more effectively. So thank you very much for your time.
Hey, wonderful. Thank you so much to both of you. Thank you, Charlotte and Danika. I think we have some time for some questions, and I have a couple for you already, some great ones. So I think I'm going to go ahead and get started. So the first question for you two, we have an audience member that wants to know which courses are needed to train a data science team?
Yeah, sure, I'll take that one. So if we think back to the slide Charlotte went through earlier in the presentation, it went through some key areas of data science. So there was the math and stats skills. So courses in just understanding when to use what modeling approach to solve your problem is one area where you would want to take courses for things. The other area is what I like to call hacking skills, and this is knowing how to program. So how to program the models and clean all of your data using programming languages. And then there's maybe the most important one, domain expertise. And this is one which you can't really learn from courses. It's practical hands-on knowledge about the field at hand. And this can only be gained through experience with the type of data you're working with and the ways that it can be applied. So I guess some courses in areas like programming, math and statistics, and then exposing yourself to the field that you're looking to apply data science to.
All right, wonderful. Thank you. Next question for you. What is the highest impact way of using data science in an e-commerce operation to drive sales? That's a great question.
Yeah, and I think if I had to generalize it, I think I saw different versions of this question in the registration form quite frequently. It was really, what's our quickest win? What's our quickest win? Unfortunately, the quickest win is 100% dependent on the business that you're working for. So I would imagine that the quickest win for an e-commerce site, if I was working with a large e-commerce commerce client, they typically have large marketing budgets. And so the very first thing that I would usually zero in on is, can we make that spend more efficient? So we would be looking at anything related to forecasting is one angle. If we want to get a bit more complex, we'd be thinking about attribution modeling or media mix modeling. But when you're trying to figure out what's going to be the most impactful for your organization, it's usually about understanding either where you're spending the most money, where you could maybe save some, or where the greatest area of opportunity is. And maybe that's an area that you already have a great deal of success in, or maybe it's an area where you know you could have some success in, but you need to dive in a little bit deeper just to understand what's going on there a little bit more.
All right, thank you for that explanation. All right, so next question that I have for you two, we have an audience participant that is inquiring about best practices, technologies, and tools to be used. There are some examples provided such as R, Python, Amazon, S3, etc. So if you can share your thoughts on that.
Yeah, that's a really general question there, and a lot of varying technologies listed. So I like to think of this sort of where you are starting out in data science or well established. So if you're starting out, you may just want to start with things like R and Python to start scripting for smaller problems. But eventually you're going to hit a point where the data you're working with can't be run on your local computer, and you're going to want to move into the cloud. And so at that point, that's when you start to need need to start looking at things like Amazon Web Services and the like. Finally, when you get to even larger data where you need to do parallel processing, now you need to start considering things like Hadoop. So sort of when you're starting out, start with the basics and step up as you lose the capability to process your data on your computer.
All right, those are some great tips. So I'm trying to get to some more questions here before we run out of time. So another question for you too, how do you translate the insights from a data science model into actionable insights and strategy?
That one's a really important question because obviously we want to use the results of our model, but it's going to vary based on the model you have. So the output from the text analysis model is going to be really different than the output of a customer lifetime value model. So they're going to have very different outputs. So the best way to know how to translate the output of your model into insights is to have access to the areas of your business you can make those optimizations. So if you have a website, you can make personalizations based upon your model output. Keep that in mind as a way of using your model. If you have different marketing channels you can change your budget on, do that. And if you have different areas to inform your marketing strategy, be it through the messaging you're using or who you're targeting, just think of all the levers you can pull in your business, and your model output should change one of those levers and allow you to change the results of what you're working with.
Okay, great. And we have an audience member that commented that they're very new to data science and web analytics, and so they wanted to know what techniques they should use to get started.
Okay, I think I have an angle for this one. So when we think about web analytics and data science and sort of how you evolve along that path, there's a way we think about it at Cardinal Path, and it's literally a path. But the very first step is your implementation step. It's your data layer step. It's about making sure that the data you acquire is as clean and as accurate and as believable by the stakeholders of the business as possible. So that's literally the foundation to everything you do before you can dive into some of these more fun applications. So step one, get the foundation in order. Step two is what we call our business layer. And that's when you start to activate the web analytics information or other analytics information that you have. And that can be through things like segmentation or reporting or the beginning of different insights projects. So things that inform your day-to-day operations. And then the final step is what we call the strategic layer, and that's really where the data science elements live. And that's where we get into all the sorts of fun stuff that you're seeing here in these different slides. But it is a very methodical progression between those different steps. You can't skip the clean data collection step and expect to really do really well in the strategic layer working on data science. You need to have sort of those foundations in place. And they also kind of correspond to how you can end up getting the most ROI out of your program, right? You don't want to go from 0 to 60 because at 60 you're not going to be able to leverage those insights as well if you miss those intermediary steps.
Great. Well, we have a sort of follow-up question to that because we have an audience member that wants to know how his business can get started with data science when they don't even know what questions to necessarily ask. So which method would you recommend to use that would benefit their business?
Yeah, I think I'm going to tie that back to my previous point about the path, and then Danika also made a point about the same thing. So think about sort of that methodical process of getting the data in order, thinking about your business operations, and then thinking about the strategic step. Can you repeat the end part of that question again? Was it about the actual techniques?
Yes, they wanted to know which method would benefit their business if they're not sure which questions to ask to how to get started using data science.
Yeah, for sure. So if you're not really sure what area is going to move the needle for your business or where there's the most questions or interest or what's going to provide the most value, we do see that when we start working with clients initially. So usually what we do there would be a series of stakeholder interviews, trying to understand the business just a little bit better or get into areas where maybe, if you are working at a business, areas that you don't currently have exposure into. And once you start to understand some of the challenges that are going on internally at the business, you can start to get a feel for maybe where data science can fit in to provide the most value.
All right, wonderful. Next question for you. Do you still have to go through the same data evaluation steps for text-based methods like you do for non-text methods?
Yeah, actually you would think that you could just throw text into a model because you need all of the text-based data, but actually there is still that same data evaluation, data preparation step that you see for numerical-based analysis. So just a couple examples, like if you're scraping web data, you're probably going to have HTML or URL encoding, which is going to give you junky results. And then even if you're using non-web data, you still have to worry about things like, does your text analytics methods, do they handle pluralization? Or do they think that plurals are completely different words, right? Because that's going to cause essentially duplicate content. Other things to think about, stop words is a thing. So the idea of stop words would be sort of non-useful words in a model. So things like I, me, you, and, the, it. Just really short words that are really common, but which would cause a bit of noise in the final output. Slang can be problematic, and then URLs can also be problematic. So those are a couple of the different things that you think about in terms of just preparing text-based data.
Well, wonderful. Well, I believe that is all the time that we have today. Charlotte and Danika, thank you so much for sharing your insight. I'm taking some time to share all this wonderful content with us. Just as a reminder to everyone, AMA members can view an archive of this webcast at any time. You just have to visit ama.org/webcast. We also do have a short survey at the end, so please take a moment to complete the post-webcast survey and just let us know your feedback and your thoughts. I want to thank our generous sponsor, Cardinal Path. Again, thank you so much. And I also want to thank ReadyTalk, who provided us with the web conferencing platform for our webcast today. If you'd like to learn more about ReadyTalk and their services, feel free to check them out at readytalk.com/AMA. And last but not least, I want to thank our great audience. Thank you so much for your time and your participation. We appreciate it, and I hope everyone has a great rest of your day.